Hi, everyone, and welcome to the last FETSA meetup of 2022. Thanks very much for joining us this evening. As usual, I'm just going to go through our slide deck and thank our sponsors. We have some recurring ones who've been with us for a long time: NML, nml.co.za, a software development company in Cape Town, and IO, where we've received a lot of support over the years from Diesel Bester. Thanks very much to them. Also a software development company in Cape Town. Go and check them out. And then we have a couple of other sponsors. React Africa is a program that we run on React, where we do talks once a month specifically around issues related to React, and that's sponsored by Vulcan Labs. Thanks very much to Ben for that. And serendipitously for our speaker tonight, we also have Code Capsules as one of our sponsors, and they've been very, very kind to help us out on the hackathons that we've been running with venues and so on. So yeah, big thanks to our sponsors. We're very grateful to them. We wouldn't be able to bring you all these events without their support. And just a couple of things that may be of interest to the community is that there are 2 conferences coming up in 2023. And there are calls for papers out on those. The first one is Node.js 1, a URL just Node.js 1, and that will be a conference in Cape Town I think it's in April, and then also in Johannesburg towards the end of the year, that is in 2023, and then kind of the grand old conference of the South African developer community, DevConf, we've been running for many years, also have their call for papers out, and that closes early next year. So if you're interested in presenting at either of those calls for papers are now open. And just finally, as I said, this is the last meetup of 2022, but we will be back in January next year with some more exciting things for you. Okay. That's it from me. I'm just going to introduce our speaker for tonight. I already mentioned Code Capsules, and Miki is the CEO of Code Capsules. We're very glad to have him tonight giving a talk. He's a full stack software engineer, many years experience, and he's going to be talking to us tonight about the benefits of state management and some patterns in Frontend. And yeah, I'm going to hand over to you, Miki, to take it away. Thanks very much.
Awesome. Thanks so much for having me. And yeah, as mentioned, my name is Mikael von Ketelhodt, but you can call me Miki or Mikael. I am the founder and CEO of Code Capsules, and I'm also a director at Abstracts Technology, which is a South African software development agency. I've been writing software professionally since about 2013. At Abstracts, we build custom software for companies, and Code Capsules is a recent project or startup that we spun out of Abstracts, which helps developers build and deploy full-stack applications to the cloud. We started that sort of platform 2 or 3 years ago to help our Abstracts and ourselves build and deploy custom software to the cloud. We really like the Heroku and Netlify sort of experience, the whole GitOps deployment experience. And we wanted to centralize a lot of the applications that we deploy and build to sort of one portal, but still cater for, whether the target is AWS or Azure or Google or stuff like that. And another sort of core change or feature is we support local servers in South Africa, which reduce the latency, which is something that Heroku and Netlify didn't have at the time. That's kind of how it started. And yeah, so the talk that I'm going to be going through today is mostly related to Code Capsules. And basically, our V1 didn't have a very sophisticated state management implementation, which, like all applications, how they all start out, it all kind of worked, but it wasn't the best user experience. Yeah, so I kind of want to just talk about some of the changes we did in our solution that result to the benefits of state management, how it helped us, and a few patterns that we implemented. And then, yeah, kind of my thoughts are that it can be a little bit engaging. So if you have any comments or questions as I go through, please fire them through the comments and we can display them and just kind of talk through them. Yeah, that's kind of where I'll be talking from. A little bit more about me personally. I enjoy hiking and exploring nature, and I'm obsessed with creating things, hence my love for software and startups. So what exactly is application state management? And I did quite a bit of reading or research on the internet. I think it's quite a broad topic. I think because we're front-end developers in South Africa, we all have heard about Redux and state management frameworks like that before. But I found this quote quite nice, which is basically, application state management is the process of maintaining knowledge of an application's inputs across multiple related data flows that form a complete business transaction or a session to understand the condition of the app at any given moment. So it's quite a big sort of quote. I can share the slides later on. You don't see the links of where I got this, but I added them to the comments so you guys can read up more. Each slide actually has some links and reference material that I can share with you later as well. But essentially, in my mind, state is everything. I believe if you structure your data correctly from the beginning, or you have a strong focus on the structure of your data all the way from the back end to the API, the middleware to your front end. If you've got that waxed, the rest of your solution is fairly easy to implement, or say easy, but I find that if your data is incorrectly structured, it makes everything a lot harder to implement. And application state management is essentially, as what it said here, is just maintaining state or session in an application. And we're mostly going to be talking from the front-end perspective, but I do want to mention a bit of the back-end as well, because essentially our applications are just representations of data. So inputs will come in, your logic will process that data and result in new data, and the UI basically just visualizes that data. So essentially, data is everything, state is everything, and that's why it's quite important. And obviously, we've all heard of frameworks like Redux and Flux, and that's what I'll kind of be talking about. Some of the code snippets that I'm going through are actually from an Angular perspective using the ngrx framework, but Redux itself is really just a pattern or a specification which can be implemented in any framework, which I'll talk through later on. From the backend data perspective, you kind of this is just one example where you can have like a set of different tables in a database that stores the ultimate result of your state or your data. So that's also very important to do. This is one example of like an ERD diagram representing relationships between your data on a backend. And this is essentially, if you're building a web application, the start of your data. So as I mentioned, if you get that right, then everything else should kind of follow along or churn quite easily. The next sort of representation of your data is your API, which in today's world, from a UI perspective, we kind of consume data from a lot of different third-party services, or the microservice pattern is very popular these days as well. So your database on the backend might look a certain way, but when it's presented via an API or a middleware, it will have already gone through one version of transformation, and that API response is sort of from the UI's perspective, the first view of the data. So that's kind of the first portal of your state and what that looks like and how it gets put into your UI. But the point of this slide is also to show that in modern applications like today, we're not, I mean, simple applications will most likely call one API or one piece of source for data, but modern applications and more complex applications will most likely consume data from various services and various APIs, which add to the complexity of state management in your UI. Which is why a framework like Redux or Flux or ngrx helps us maintain that state quite nicely. So as I mentioned, most applications start out quite simply like this, and this applies to any front-end framework, whether it's Angular or React or Vue. You kind of have a state or a component tree or a document object model, which will look quite simply like this. Like you might have your core app, you might have one or two pages, and those pages might have a header and a footer or some buttons, etc. So every application starts off like this. We don't think about state management at all. We just want to iterate and get our features going. And this is typically how every application starts. But over time, our applications start to become a bit more complex. As I said, as you start consuming more data or implementing more logic, needing to integrate into various APIs, soon your pages and components need to share data or share logic, communicate with each other. And this is another reason for implementing a decent state management system. And this is the exact route that we followed. We kind of had a very simple app, and over time, we implemented in Angular the service pattern. Probably also didn't implement the service-based pattern as best practice as is out there now. That's kind of how we iterated. We kind of had a set of services that would call an API and then just return the data, but we didn't really manage that state very, very correctly. We didn't implement a state management system, which is fine. Sorry about that. It's fine initially, like as I said, your application will work, it'll function, but for a few reasons, which I'll show you the next slide. I don't know if you can see that. It should be a GIF loading, but anyway, I'll explain what does happen. I'll show you a link later on. Because we implemented services that looked a little bit like this, over here, this is just one code snippet example. We have a space service with a function called getSpaceBySlug. And this function just called an HTTP service that fetched data from an endpoint and just returned the data straight away. So we weren't storing this data or managing this data. It just did a call, returned the data to the component or the page, and that was that. And what this GIF is supposed to show on the screen is our V1, where a user navigates through the app, and after every button that they press or every new page that they go to, it's reloading data again. So what ended up happening is we might have had multiple API calls to the same API, duplicate data, or data that was out of sync with the way that we implemented services here, which could have also been done better, but that's just typically how applications go as you iterate. So we ended up with a really poor user experience, even though things worked. And I see a lot of applications kind of follow the same route, where eventually you need to implement some form of state management, whether it's through services or through Flux or through Redux, etc. And that's kind of how we ended up here. Yeah, are there any questions so far? Or let me know if I'm going a bit too fast. I'm also just kind of going through the journey. Yeah. So that's how we ended up here, which we end up looking at Redux, or more specifically the ngrx framework in Angular, because our solution is in Angular. And this is a very simple representation of what Redux is. I believe Redux was first born from the Flux pattern, which came from Facebook, if I believe so correctly. Can anybody tell me the difference between Flux and Redux, if you know the term? No, all good. So essentially, Flux.
I can.
Sure.
Single versus multiple, right? Simply put.
Yes, that's correct. Yeah. So Flux basically manages
stores, I should say. Single versus multiple stores. Yeah.
Correct. Yeah. So Flux manages or implements multiple stores, whereas Redux implements one single central state or store. And we kind of like that pattern or that approach, which is represented in this diagram over here. So as you can see at the bottom, the new state or current state is basically your store, and that's where in the Redux pattern your entire data is stored or defined in one central place. And I'll run through a few slides later on what that sort of state tree looks like, and especially in our case. And these 4 or 5 little pieces of the diagram make up the Redux pattern. So your data is stored in the store, in the state. Your components get updates on any kind of new data that's updated in the state. And I'll explain a little bit more about how that works. And your components trigger what are called actions. And whenever an action is dispatched to the Redux framework, it goes through the reducer. And a reducer is essentially a idempotent function that takes the current state and a new action with a piece of data and is supposed to result in a new state. So that's the whole idea. And if you read more about Redux, they kind of also advertise the whole debugging features, which you can kind of go forward and backwards in your state history very easily, because everything goes through the reducer and produces new state from old state. So there are a lot of nice features over and above what I'm kind of going through today. To enhance that further, and I don't know if this only applies to Angular or ngrx, but you can add what's called a select on top of that. Because as I mentioned, your data goes through various transformations or various versions from the backend to the API, etc. Once it lands in the state, you might only want, your components might only be interested in certain slices or certain pieces of the state. So it's a best practice to kind of define what's called a selector that will get notified anytime the state changes and return sort of a filtered down part of the state that your component is interested in, which is quite nice as well. And I'll run through some examples later on. And then a final component that can be added as well is something called an effect. I think in React they call it a thunk or a middleware, but essentially an effect, similar to Reducer, it listens for actions that get dispatched to the store. And in the ngrx case, an effect will result in another action being fired to the reducer. So an example here, effects and middleware in Redux are often used for API calls or sort of side effects to the state. For example, if we dispatch an action called fetch teams or fetch spaces, the effect will listen for it and say, cool, whenever the fetch teams action is fired, I need to go off to the API, either through a service or directly to the API, get that data, and then map it to a new action called fetch team success, for example, which will then fire off another action with the array of teams or whatever data that is to the reducer, which will then amend the current state to the new state with the data that was fetched. So these are essentially all the components to Redux. So just to summarize, the store is where everything is stored. That's where all the data sits, essentially. Your selectors retrieve state or a state slice from the store or a filtered down version of your state. Actions essentially notify Redux of an event with a piece of data that needs to impact the store or go through the reducer to update to a new state. And your reducer is basically an idempotent function that takes the action in your old state and produces a new state. And an effect is essentially a side effect or middleware that maps one action to a new action. And we'll see some examples of that shortly as well. So this is an example of what your root state could look like in a TypeScript scenario. So again, this is Angular, TypeScript, ngrx, but it applies to React or Vue as well, I suppose. So we have an interface called state, and we define individual slices. So in our example, we've got invoice, which is defined by the invoice state, space, which is defined by the space state, team, which is defined by the team state, et cetera, et cetera. So it's a little bit of best practice to kind of structure your state into various features or various slices, as they call them, to not just, you don't have to have everything in one file. We kind of break it up, as you can see on the right here. In our state folder, we've got a different folder for each sort of feature or state slice. And within that folder, we then structure all of our actions and effects and reducers and selectors inside there. This would be an example of the space state itself. So you can see that we store an array of spaces, we store the current state, and we might store other stuff in there, which I'll run through later on as well. So this is quite nice, especially if you're using TypeScript. You can kind of strictly type your state, which becomes very nice for development as well. And if you follow this sort of folder structure, you can kind of just keep adding more slices and features, which will naturally happen as your app grows. So you can kind of organize your data and your state in one spot, and just combine the state together. So that's kind of what we did. So remember the service-based approach that I mentioned earlier, and that was quite a simple example where you're fetching a space from as a result from the route changing, and you might use that service among other pieces of logic in various pages or components. Whereas now with a selector, your component, and it could be any component that needs the current space, just implements or stores the observable in the Angular case, where this variable will now get notified every time the current space changes. So you can implement the selector on any component, multiple pages, multiple components that are interested or need to know the current space. So anytime the reducer or the state gets updated, this variable gets updated with new data. So that solves our problem from earlier, where we might have had 2 pages calling the same API in duplicate, but then it's just recording that data in different variables. Whereas in this case, because we're using Redux, which essentially stores that piece of data, the current space in here, this variable over there, we're confident that it can only ever get updated from one action through the reducer, and whenever that action gets updated, or the state gets updated, any component that's listening through the selector will get that new piece of data, which is really, really cool. And this is the definition of that function. There's a function called create selector from the ngrx framework, and again, I'm sure there's similar implementations on React and Vue. And essentially, in this case, we passed in the spaces slice, but you can see here that you can pass in a callback where you get the state that you're interested in, and then you can just return a slice of that state. So in our example here, I was only interested in the current space slice, not everything else, and that's what the selector over here does, the selector current space. And you can kind of create different selectors for example, if you needed to select a space by ID, you could implement a selector, pass in the space state, and then whenever the array of spaces gets updated, the selector would fire, and you could then say return state.spaces.filter, where the space ID is equal to whatever the parameter is. So that's quite cool. Here's just a very simple example of dispatching actions. So remember, any state gets updated only as a result of an action through the reducer. So you would use the store object dispatch. Again, we've used a tightly, strictly typed action called fetch spaces. And that will then go through the effect and the reducers to then update the store, which will then ultimately update the selector and ultimately update the component to visualize that data. In this example, we fire off the fetch spaces action, but you'll notice in this example here, this is a snippet showing what the reducer looks like. But you'll see that it says on space actions fetch spaces success, whereas earlier we fired off the fetch spaces action. And essentially what happens is the fetch spaces action gets put through an effect, and that effect then does an API call to fetch spaces, which results in then the fetch spaces success action being fired, which then has the array of spaces, because fetch spaces we don't have that data. It has to come through an effect or a middleware, which is what the effect does. And this is then the snippet where we get the current state, we get the new piece of data from the result of this payload or this action. In this case, we just return a copy of the state and override it with the new data. So in this case, the new array of spaces, and we just say loading false and loaded at, or whatever other logic or data you want to store as a result of this action. And this reducer will then return this new object, which is the amended state. And that leads us, I think I got the slides a little bit wrong, but essentially, here's what a effect looks like, at least in Angular. We can listen for various types of actions. So you can see they're highlighted in bold: fetch teams, or login success, or fetch spaces. And that will then fire off another function to where you can put any kind of asynchronous logic or any kind of logic as an effect or a middleware of this action. In this example, whenever the fetch teams action gets fired or the login success action gets fired, it then does another API call to fetching teams. I think I've got a better slide later on that portrays that a little bit better. but let me just move on. Yeah, that's, I think, a bit of a summary on Redux and actions, effects, spaces, reduces. And I think I mentioned a few of the benefits of, initially I mentioned some of the problems we had, and through a few of these examples, some of the benefits that we've already been receiving from implementing Redux in our application. And more specifically, the problem where, as a user navigates through the application, it has to reload data every time. So essentially, storing that data helps, which means whenever that data is essentially available, all the components get updated. And what's really, really cool with these effects, and I'll show you an example of what we did, is we did what was called chaining actions or effects together to fetch all the data that was necessary for the user once they've logged in. Here's a screenshot of our new dashboard. I'm trying to basically show, I'll demo this later. But essentially, as soon as the user logs in, we then fire off, and on the right here, you'll see all the successful API calls to plans, customer, spaces, teams, phone numbers, regions, clusters, usage. And essentially what we did was, as soon as the user logs in or is logged in, we only fire off the login success action. And because we can filter or listen to many actions on all the effects, we listen to not just the main action that triggers this effect, but also the login success for sort of our root data, which would look something like this. So when the user logs in successfully, we fire off the login success action. And then all the other state slices or features, for example, teams, spaces, customers, plans, usage, they will fire off as a result of that login success. So why that's really cool is that we just have to dispatch one action, which is the login success, and then all the other effects will fetch teams, fetch spaces, fetch all the data we need to populate the store that the user might need, so that when the user is browsing around, there's no loading sign. The data is already loaded, and the user experience is heavily improved. And I mostly focus on this one over here, this example, because so level 1 is the user logs in. That results in A, B, C, D, E, F. And then on B, when the spaces were successfully selected, we had to make a further call. And this is very specific to our application, but it was quite handy. Essentially, it's a very simplified or dumbed down version of our architecture. As I mentioned, UI or modern UI, complex UI applications consume data from multiple endpoints or APIs. So in our case, we've got a separate billing API, a separate sort of main API, a separate auth API, and then each of our regions and clusters. So when you as a user create a space on Code Capsules, you have to select a region. And that's essentially then where your applications will get deployed to. So if you want to deploy an application to the US or to Europe or to South Africa, you have to first create a space and select that region. That physically is actually going to live on a different API or a different instance of an API, which is our cluster or Capsules API. And we were only able to fetch or create capsules once we know which space and which cluster region you're deploying to. So that kind of added a bit more complexity to our state management or our data, which means we depend on a space before we can fetch or create capsules. So we changed it even further, where as a result of the spaces being returned successfully, we then had an effect that looped through those spaces and just fetched the first 10 capsules of each space. Because a user might have capsules in the US, in Europe, in South Africa. They could have, as you can see here, this user's got 113 capsules across 46 spaces and 24 different teams. Those could be in any cluster region. Luckily, because it's all asynchronous, I'll demo it later on. Because the user's just logged in, this data is being loaded asynchronously in the background. And it's likely that the user will then start to navigate, and by the time they navigate to a team or a space or a capsule, that data is already loaded, and it will feel super fast, super snappy, and those are some of the benefits we've received from this pattern over here. Just to dive into a bit of a code snippet, this was the effect. We called it fetch spaces capsules. So as a result of the spaces being returned successfully, we got an array of spaces. we mapped that to an individual space, and then we implemented this merge map function here, which means for every space in the array here, this function would fire, which then allowed us to find the spaces clusters API endpoint, which was different from our main API, to then be able to fetch the user's capsules from that space. And then we return a new action called fetch spaces capsule success, which allowed the reducer to then store those capsules against that space. I think that was arguably the most sort of nested piece of data that we had, but that leads us to another sort of pattern that we realized, or another little trick that we needed to implement, or that we realized was you might have a lot of nested data or slices in your state, but we wanted to, for example, filter capsules by a team or filter capsules by a customer. And the way that this state is currently stored in this example, you'd have to write a selector that goes through teams, then spaces, all the way down to capsules, and then filter, does this capsule belong to this team, etc. So the selectors are taking a bit of time because the nesting of the data was quite complex. Hey, Scott. So that led us to another pattern over here, which is essentially defining your state as a map or a hash map as opposed to an array. So here's a simple example I showed earlier, our space state, which had an array of spaces. You might have an array of capsules in your space, or which is in another array of spaces in team. And the data would then look like this, where you've got an array of capsules. But we wanted to select capsules by team. This is a dumbed down example because in our case, we didn't actually have team stored on a capsule because you needed to first find the team to find the space to be able to access the capsules which knew nothing about the team. So this is actually a poor example. But what I'm trying to get to at is you can define another slice in your state that might have the same type of data or just a different view of the same data. And it looks something like this, where we, instead of storing an array of capsules, we store an object mapped by, in this example, team ID. So we have a variable called capsules by team ID, which is an object, not an array, where the key is the team ID that then stored, okay, again, this example is not really great. It should actually be an array of capsules so that you can then easily select all the capsules by that team. So your selector then just passes in the team ID, and because the data's already been fetched, it's just been organized in this object map as opposed to an array, the selector becomes very, very simple and arguably a lot faster to query as well because it's in a hash map, not an array. So you can, because it's keyed and unique, you can just fetch the array of capsules by a team ID or any other way that you might need to access your data. So that was another neat little trick that we implemented as part of our solution. Another challenge that we found, and I think this applies to React and Vue and Angular as well, is if you need to operate on two different slices of state, you often, at least in Angular, you end up with something like this in your components where you use something, a function called combine latest, where you'll select 2 or 3 different slices of state, pipe it, and then do some sort of mapping or operation on it. And this can very quickly sort of make your components very messy or complicated. And what we found, and I think we still have some, we still have some instances in our code base that are a little bit like this, but I think the better practice is to implement a selector where you can actually pass in multiple different selectors. So the bottom one over here, create selector, where you get the all item selector and the cart ID selector, and then operate or return your map, or your transformed view or selection of that data based on that data. So basically, instead of using combine latest and various operations and subscriptions in your components, rather create a combined selector. It was the lesson that we learned from our exercise over here. One thing, and this is probably also very specific to Angular, is to close your subscriptions. So the variables that are returned from the selector are actually observables, which means you can subscribe to them in your TypeScript or from your HTML code. But because they are observables, if you no longer need them or you're not on the page or your component might still live but is not being used, just make sure to unsubscribe from those observables to not end up with any memory leaks or poor performance. That can very easily happen if you have a lot of observables, especially in Angular. Just make sure you're unsubscribing or destroying your components properly. That was another lesson we learned. If all your components are subscribed to various slices of the data, that can very easily result in a bit of memory performance issues. And then I think lastly, there was a really cool feature we implemented, and I might switch over to sharing my screen to show you the few benefits that we received. We wanted to implement a sort of, because one main sort of downside to our V1 was the user experience on navigating from once you've logged in to your team, your space, your capsule. It took like 3 or 4 clicks to get to the capsule that you wanted to get to. And especially if you're in one capsule and you want to navigate to a different space's capsule, you have to go all the way back, then all the way down. And because our services were loading the data all the time, it was not just the clicks, but also the loading of that data as we went through. So I'll demo the improvement of that along with this little feature that we implemented. Because we had all of our data in a central state, we then had a component, like a central search component, that we subscribed to the main state. And we then just implemented what was called like a fuzzy search completely client-side. So we subscribed to the teams, the spaces, the capsules, any kind of core entity that the user might search for or type on. And we stored it in a structure like this. We called it like a group, was either teams or space with an icon. We stored the name of the slug and a route to link. And we used a library called Fuse, or Fuzzy, I don't know how you pronounce it. But essentially it looks something like this. We just pass in the data that you want sort of fuzzy searched. This can work on the front end or the back end, but because we had all of the data, the state for the user in the front end, it was fairly easy to implement there, reduced our API calls, and it made the user experience really, really cool. And so this basically says data on teams and spaces and capsules. I want to do a threshold of 0.3 fuzzy search on name and slug. And I'll demonstrate what that looks like on our application. I'll share my screen. I think you need to switch the screen that's being presented. I don't have that. Yeah, thanks. So everyone can see my screen? Yeah. So also to note, thanks, yeah. At this point, I've already logged in. I have been logged in. And actually in the background, even before I've gone to the dashboard, that login success action should have already fired. So if I refresh the page here, you'll see this is only if you're logged in, but a lot of the data, see all these capsule calls are being made across the various clusters that this user's a part of, which means as soon as I go to the dashboard, all that data is already loaded. So I can very quickly navigate to the capsule that I need to. I can filter by teams and spaces, capsules, etc. Whereas in our V1, even just to get into a capsule or to a space and a team took a very long time. So that's some of the benefits of centralizing all the data in one place. And then that search bar that I was talking about is this one over here. So if I type in something like, you can see it's like a fuzzy search across all the capsules, teams, spaces, in the state that we've got stored. And then that's how we implemented that. So some of the benefits of keeping the state and data centrally stored. And that's about it. I'm going to stop sharing. And then can put the slides back on. Yeah, just to summarize, some of the key learnings, among others, nice folder structure helps you to maintain the complexity of your application as it grows. So we group state slices into different features. We use types for action selectors and state, in this case Typescript, which is really nice. Simplify components as much as possible by only using named selectors as opposed to selecting from the store or combining different slices of the store. To also then structure them to be queryable, map versus array, or whatever data format you need your data to be in. Over and above all this, I still like to follow the smart and dumb component flow, where your smarter components should sort of subscribe to the store, and your dumb components should just pass data in and out. I know that some people advocate for Redux or a centralized state management allows all of your components to kind of share the data, but I think it's still nicer to kind of have components that don't know anything about state or logic and just have data that comes in and data that comes out, and then still keep your smart components like your pages connecting to the state and the store and your logic and just passing the data in, which is something I didn't show an example of, but something that I still like to advocate for and follow. And then chaining effects to fetch all the needed data, which might not be applicable to all applications, but it worked really nice in our case, as you saw, because our data is separated across like 10s to 20s different instances of APIs. Yeah, and that's basically it. Are there any questions?
Any questions from anyone on the stream? Sculp, you always have questions. I don't know if he's still there. Okay, it doesn't look like we're getting anything. Yeah, I just want to say thank you so much for the talk. It was really interesting. It's always great to have talks that aren't just some kind of an abstract idea, but rather speak about real problems that you've solved. So very, very nice to have that. And yeah, I really like your idea of like the state being the fundamental building block of your application rather than your components. And I definitely think we all tend to go components and then and then look at how we're going to manage them afterwards. So yeah, I really enjoyed that. I really enjoyed the idea of looking at state as the kind of fundamental thing we need to be looking at before we even start thinking about those things. So yeah, that was really great. Thank you very much.
Awesome. Yeah, thanks so much for having me. And yeah, it's great to talk, and yeah, hopefully see you everyone in the new year. Yeah,
great. Thanks again. I'll post, I've got the link you shared to your slides, so I'll just post that in the chat, and we'll also share it on the Slack channels. And the recording will be available. It usually takes Google about 24 hours to pass and to render the whole thing. And then we'll share it again in the Slack channels. Yeah, great.
Awesome. Great. Thanks so much.
Thanks again. Thanks so much.
Cool.
Bye, everyone.